Hi everyone. In block 4, now we are going to see unit number 11. In unit number 11, we have the structures. So let us see the objectives, introduction, and what are the classifications of index numbers and methods of constructing the index numbers. Under that, we are having that unweighted index number and what is weighted index number. And 11.6 splicing and inflation uh, index number we will see. And then some of and the keywords and terminal questions we have. So we share that what we have. Okay. So these are the structures we are having 11.0, 11.1 to 11.9 we have. So in this one, what is that objective we are having? What is our objective of our study in this index number? So here in this unit, we are going to identify the classification of index number for different environments. And the next one is apply and calculate the index numbers using different methods. And the third one is describe the limitations of index number to avoid errors in interpretation. So these are our objectives in our study. So let us see the introduction. So different methods of indices give different results when we apply to the same data. We are having so many methods or so many uh, results we can do. So at this one, how we are going to get this one. So utmost care must be taken in selecting the formulas which is most suitable for purpose. Whether to as an unweighted or weighted index is a different question to answer. So it depends upon the purpose for which the index number is required to be used. So for example, if you consider if you are interested in an index for the purpose of negotiating wages or compensating of a price rise, only a weighted index so workful can be used. So how we are going to identify this is weighted index, how we are going to use this one. So, which weights are to be used? So, based on that, whether base year quantities or current year quantities. So, I think so. We are very known with that base year quantity, and what about the current year? So, base year when more 2 years are compared. Suppose if you are considering 2000. 4 and the 2000 we have means 2004 we can consider as a current year and 2000 we can consider as basic. So that already we are aware of that one. So based on the base year and the current year quantities we are considering. So already we have seen the prices. So here we are doing comparison quantities. So quantities based wise we are doing the comparison or some other weights are used to in important question to answer. So weights which realistically reflect the relative importance of item included in the construction of an index. So this is the basic we are having that weighted index. So next one we will see that classification of index number. So how we are going to do the classification? So we are having the principle. There is basically we are having price index, quantity index, and the value index. These are the three main types of indices we are going to construct. So the very first one we will see price index. Okay. So what do you mean by price index? This type of indices is most frequently we are using. So price index indices consider prices of a commodity or a group of commodities. We are doing the comparison. and compare changes of prices from one period to another period. So usually we are taking that we are doing the comparison of any two commodity. If you are taking a commodity, when you are taking that comparison of any 2 year, 1 year we are considering as a base year, another year we are considering as a current year, means based on there is one period it may have a period, one period to another period. So also the compared difference in price from one place to another place. So one place we may have the price of one commodity will be lesser. The same commodity when you see in some other places it will be higher. So suppose if you consider any other commodity, electronic purchases, if you are comparing in India, it is higher. If you compare in US, it is less. So it differs. The price is differing from place to place. It is different. So that's that we are considering. So for example, for a familiar, here we are taking the example. For example, a familiar consumer price index ensuring overall price changes of consumer commodities and services is used to define the cost of. So according to the cost of living, also we have that price index number. That's the thing we have under this um, price. So here the notations we can use for price index as P we are using, and for base year we are considering as P naught, P suffix not we consider, and for current year we can consider the price index as P1. So usually we are using this notation for price indices for base year and current year. Okay, so the next one we will see that. So here in this manner, according to from place to place, it may vary. So this is the price index number we are taking. And the next one is quantity index. Quantity indices. So this the major focus of consideration and comparison is these indices of the quantities either of a single commodity or a group of commodities. For example, focus may be to understand the changes in quantity of maybe production in India over different time periods. So this is one example we are taking. So paddy production in different periods we have in different places also we have. So what is that the quantity? How much of quantity we have produced? So that depending upon the places or depending upon the period, also we can use quantity. So for this purpose, a simple commodities quantity index will have to be considered. So alternatively, the focus may be to understand the changes in food grain production in India. In this case, all the commodities which are categorized under food grains will be considered while constructing the quantity. So this is coming under. Now we will see that value index. So here we have seen the price index and we have seen the quantity index, and now we will see that value index. So what do I mean by this value index? So value indices are actually measure the combined effects of price and quantity changes. So for many situations, either a price index or quantity index may not be enough for purpose of comparison. For example, an index may be needed to compare cost of living for a specific group of person in a city or a region. So here the comparison of expenditure of a typical family of group is more relevant. So here we are considering this. So according to this, we are doing the comparison So this is comparing that is expenditure is the value of the index which we have to construct. So where we are using this usual in where we are having this production decision. So there we can use this value indices. So in production decisions we can make use of this value indices since it avoids effect of inflations. So according to that reason we can use this value indices. And so these are the three main indices we are using in the index number. So and then here we can say the formulas we have for this value indices. So here under the I said P1. So P1, the value indices formula we have given by that is summation P1 Q1 by summation P0 Q1 into 100. So the value we have usually we are representing summation P1. P1 is referring price index of the current year. P0 is referring current, that is price of the commodity of the base year. So usually the suffix not we are representing for this year, suffix one we are representing for current year. So what we are taking in terms of percentage. So we are considering in 200. The next one is these are the self-assessment exercise questions for you. So state the reason. The questions are state with the reasons whether the following statements are true or false. So some work exercise questions for work. So in the index numbers or specialized averages, whether they are specialized averages or not, this is true or false. And then the index number for a base year is always 0. And then the next one is a value index measures either price or quantity changes. In times of inflation, a quantity index provides a better measure of actual output than the corresponding value index. So this is the true or false we have to say. And then the next one is though the appropriate indices normal increase can be transformed into real income. And the next one is probability sampling. So you are aware of that one. Probability sampling is the most appropriate method for selecting the commodities while constructing the indices. So already we are saying we cannot include all the commodity in when you are constructing the price index number. So which type of how we are going to select that commodities by using. So they are saying that probability sampling is the most appropriate method. So what are the methods are available, and we have to state that whether this method, that is probability sampling, is most appropriate method for selecting the commodities while constructing the indices. That to say it is true. For they are saying that it is appropriate method. So we have to say it's true or false. And the next one is a base period may be described as a normal period if it is the most recent period for which we have data. So a base period can be described as a normal period. Okay, so that's I believe we have seen what in by base period, base year or base period we have seen. And similarly, we have seen what do you mean by current period or current year. So how we have to take, normally we have seen, it is if it is the most recent period for which we have. So this type of period difference we have to take. So that already we have seen. So whether this is true or false, we have to see. Okay. And the next one is second question is in magazines and newspapers, you might have come across many index numbers. Name four such index numbers and briefly state what does each of them indicate. So this is the you might have known about that index numbers. What are the index numbers you know? So that you have to mention. So name such four index numbers. So what you have learned about that. So usually regular life, what you have come across, that you have to list out. And then third question, list of problems that arise in relation to the construction of a index number. So already we have seen this topic. What are the issues we are coming across when we are constructing the index number? So under that, they are what are the problems arise. So that we have to list out, and then try to cite one example which where price index, quantity index, and value index is not appropriate. So you have to one give an example, price index for one for quantity index and another one for value index, which is not appropriate. That is not appropriate. That you have to give one example. It's not appropriate. And then in this next one, we are going to see. So just if you are recalling that what we have seen. So let us see. So already we have seen uh, what are the main three main indices we have listed. So the first one is we have seen the price index, and the next one is quantity index, and the next one is third one is uh, value index. So under this, how we are going to construct the index number. So the methods we are so that's the thing. So value. So we have listed all these indices. Now we are going to focus on the construction of price and quantity index indices and their limitations. So these are the things we are going to see. So different formula have been introduced by statistician for constructing composite index numbers. So they may be categorized in two board groups as given below. So already we have seen so many authors or so many statisticians have defined what do you mean by index number. So many definitions they have given. So now we are to two broad groups we are classified. So one is unweighted indices and another one is weighted indices. So first thing is unweighted indices. The formula and its use is constructing each category of indices are listed above, and they are discussed in the following sections. Okay, so let us see what are the notations we are using, what are the symbols we are using in constructing the text number. So already, so P naught, the P naught is representing price. Price per unit of a commodity in the base period. So suffix naught is representing the price for a commodity in the base period. And P1 is the thing, but it denotes the price per unit of same commodity in the current period. So already we know what do you mean by base period and what do you mean by current period or base year or current year. You know, if suppose if 2 years are given means we should know which year you are going to select as a base year and which year you are going to select as a current year. That already we have discussed. Okay, so now we are going to see which index number is calculated. There is current year, current period is the one in which the index number is calculated with reference to the base period. So similar measurements are assigned to, so the same, assigned to quantity index as well as for value. So Q naught Q1 and P naught P1. Okay. So and similarly the capital letters PQG, PQB, these are nothing but price index, quantity index, and value index numbers respectively. So P naught 1 refers to the price index for the period 1. And with respect to the period P naught, so P naught 1 is the price. So we are having the suffix, uh, just we are recalling that suffix naught is representing the base period, P1 is representing, suffix 1 is representing for current year, and we are denoting this P suffix. In the suffix, we are denoting not 1. So this P not 1 refers to that's price index for the period 1. Okay, so that we have. So similar meaning is assigned we can have for that quantity and then for value. So Q not 1 and then not 1. So this is the notations we have under this quantity and as well as the value indices. So here always we are representing that indices in terms of percentage. So when we are doing the comparing the price files or maybe in the other text we have price index, quantity index, or value index, all these things we are going to represent in terms of percentage. So in 2000, what was the price? And now 2022, what is the price? So the price has been increased or decreased is how much of percentage. If it is increased, is how much of percentage it has been increased. So in terms of percentage, we are giving the index. Okay, so that we do. And the next one is 11.4 unweighted index. So this type of indices are also referred. Okay. So unweighted index number. So this type of indices are also referred to as simple index number. Simple index number. And so in this unweighted index number, we are going to so unweighted index number, we are having that subdivision as simple aggregative and simple average relative index. So further classifications we have under this unweighted index number. So that we have. So So here their weights are not expressively assigned. So we are having that main two categories, simple aggregative index and simple average relative index. So the first one, simple aggregative method or simple aggregative index. So what's this? What is this? So this is the simplest method of constructing the index number. Okay. So when this method is used to construct a price index, the total of current year price for various commodities in question is divided by the total of the base year price and the quotient is multiplied by 100. That's the formula we have. So that's the wordings we have. So usually we have P naught 1. Already we have seen P suffix not 1 means it is representing the notation we are using for price index. So P not 1, it is nothing but it is representing price index number that is equal to summation of P1 divided by P naught into 100. So this summation P1 is nothing but what? So total current year prices for various commodities. Okay, and then summation P naught is total of base year prices for various commodities. So this method of constructing the index is the simplest of all the methods. So this is a very simple method we are having, and as usual, so the same can be applied for quantity indexes. So Q naught 1. Q naught 1 equal to summation Q1 by summation Q0 into 100. So summation Q1 by Q0 into 100 we have. So summation Q1 already you know. So this is the total of current year quantity for various commodities, and the summation Q0 is total of base year quantity for various. So these are the uh, equations and these are the formulas we are having for finding the price index and commodity index. This is the very simplest method to find the simplest formula for finding the price index. And now we, for example, consider the simple data given below for 1990 and 2000 for construction of a price index and quantity index. So, here is the items, so the commodities we are having: wheat, clothing, gas, electricity, and house rent. Here they are given. Okay. So items we have and the items or commodities we may have. So corresponding the 2 years we are doing the comparison, 1990 and year 2000 we are doing the comparison. So corresponding year, price and quantity we have given. So price in rupees they have given, and the quantity the units are different. Okay, so summation usually we are representing as we discussed. So price index, there is the price of a commodity in the base row each year. Here we are taking the years 1990 and 2000 means I have to consider 1990 as a base year and the 2000 as a current year. So the corresponding price of 1990 I have to consider as P naught, and the corresponding quantity in that is for 1990 as Q. And similarly, the price for 2000 as P1 and the quantity for year 2000 as Q. That's the notation we are. So here I am doing the summation of P naught, summation of P naught. I'm adding all that price. So P naught I'm taking. So summation P naught and the summation Q naught we are finding, and then summation P1. P1 is price index of current year. So P1 we are calculating, summation Q1 we are calculating. So here we are computing that index by the single aggregated method, that is simple aggregative method. Price index, that is P naught 1. Price index is usually referred by that notation P naught 1. So P naught 1 equal to summation P1 by P naught into 100. So that is, we got the total as 2271.1 by summation P naught we have as 1450.8, which is I have done from the table we have. So into 100. So in terms of percentage we are taking. So 156. So 156.54. So thus the prices in respective commodities considered in the index shown with this of this one. So 156.5. So 56.54 percentage it has increased when you compare with 1990. So in 2000 we have 56.54 percentage the increment. So likewise, we can calculate for any commodity. So this is the simple illustrations we are having in the book. The next one is the limitations. So this method from the following two limitations. So the unit size affects the index number here. So for example, for instance, I see that above illustration we have the price of wheat was quoted in, that's why I said in kg, in kilogram we have, but but in that is in rupees and 9.5 in 2000. The index might be very different. So that's the main limitations we are having. So the second point is the relative importance of different commodities is not reflected in the index. So it will not reflect in the index. So for example, in the above illustration, a total of rupees 2,800 spent on wheat. This is the most important item of expenditure. So this is not reflected in this. Okay. So how we are doing the analog? The quantity index by the simple aggregate method is Q01 is given by summation Q1 by summation Q0 into 100. So how we get for that price index? So yes, we are having for the quantity index also. So Q01 is given by summation Q1 by summation Q0 into 100. And we have so the illustrations we have for the quantity index. So Q0 1 is equal to, we are getting 124.61. So increment of 24.61 percentage. So here you should note that if this P in the formula is a price index is replaced by Q in constructing the index. This expression is applicable to the formula of different methods also. So here also the limitations we are having, the units of quantities being different cannot be added and the quantities do not present the appropriate variables for the purpose of comparing the expenditure. And the second one, simple average of relative index. So in this method, we already we have here we are constructing the price index. So here first of all, price relative is computed for different items, included the index, and then the average of these is calculated. So here is the formula what we have. P01. P01 is given by um, summation of P1 by P0 into 100 divided by N. N is nothing but number of items. So sum of the price relatives. Sum of the price relatives divided by number of items. Otherwise, we can summation of P1 by P0 into 100 divided by N. So using the same data by considering only prices given in illustration, the computation is price index as a simple average of price relative is as follows. We will see that the illustrations we have. So items we have is heat, clothing, gas, electricity, and housing we are having. And when you see that units we numbers detail that different type of units we are having meter. So the units we have. So here we are having that price 700, 200, 150, 0.80, 400 like this. So in the year we are having the prices 950, 300 like this. So price relative, we are calculating the price relative, you see. So in year there is usually 19,990 year and 2000 year 2000 we are doing the comparison means we can have this 2000 year as the current year and the 1990 as this year. So corresponding we are taking. So we will consider that price there is for all the price we will 2000 we consider as a P1 and P0 for 1990. So P1 by P0 into 9. So for B, the corresponding P1 is 950 and the corresponding P0 is 700. So 950 by the last column shows 950 by 700 into 100. So the percentage we have is 135.7. And then similarly in clothing, so we are having the different commodities we are considering with the different units. So clothing we have is 300 by 200 into 100. So this is 150. So 50 percentage increment. So the previous one we increment of 35.7 percentage. 35.7 percentage. So in gas we have as see 150 and 220 we have. So 220 by 150 into 100. Okay. So the percentage we have is 140.7. So 40.7 percentage increase. And in the electricity we have 0.80, 1.10. So 1.10, so P naught, sorry, P1 is 1.10, P naught is 0.80. So 1.10 by 0.8, so into 100. So 137.5 means 37.5 percentage. And then in housing, and see that units we have, and for 1990 and 2000 the values we have. So P naught by P1, so 800 by 400 into 100. So we are taking the summation of all this. So we have 763.9. So P naught 1, the price index, P naught 1 is given by summation of P1 by P naught into 100 by N. So totally we are having the commodities. Number of commodities we are having is 5. So 763.9 divided by 5. So it is 152.78. And the corresponding Q01. Q01 is nothing but quantity index. So quantity index number is summation of Q1 by summation Q0 into divided by N. So N is nothing but number of commodities. So here the index of simple average of price relatives shows 52.78 percentage increase in price. So for constructing the quantity index, the quantity relative should be combined and average. So the formula for quantity index in this method is so this is the formula. That is Q01 is given by the formula is Q01 is given by summation of Q1 by Q0 into 100 by N. So which you may compute on your own by saying there is an illustration 7 how we did. So the same pattern you can have this for quantity. So this method is also has its limitations. So uh, each premise quantity relative is given equal importance, which is not realistic. And secondly, the arithmetic mean is not a right type of average of ratios and percentages. And we have as this self-assessment. We have um, calculate the price index number by simple aggregate and average of related methods from the following data. So here I have to say what are the limitations of both these methods. So commodities and price in 1996 and the price in 2000 year in terms of rupees that is the unit is rupees. So what are the limitations of this both methods we have. And next we will see 11.5. The next session we are weighted index numbers. So previously we have seen unweighted index number. So this is weighted index number. So already we have discussed about this unweighted index number. It is in the true sense of the term we have discussed. So as that is we assign equal importance to all the items included in the index, and as such as they are in reality weighted. So weights being implicit rather than the explicit. So as we discussed earlier, the unweighted indices, it is possible to get different results by changing the implicit weighting or the unweighted index we can have. So it's far from the realistic is the most like cases. So here we are going to, as how we discussed in that unweighted index number, here also we are having the two types. Uh, One is weighted aggregate index and another one is weighted average of relatives. Relative index. So these are the two main divisions we have. So let us discuss the two methods one after another. So one is the first one is the weighted aggregate index we have. In this group, we shall three methods, or commonly we are using this index. So the first one is the very familiar three methods we have. First one is last year's index, and another one is Cauchy's method, and another one is Fisher's index. So basically, we are having these three. But we are having six. So totally, we can have six methods in this weighted average aggregating basis. So last year's method, Cauchy's method, Dervish and Bowley's method we have, and Fisher's ideal index, Fisher's ideal index already we have. So apart from that, we have Marshall Edgeworth method also we have, and Kelly's method. Kelly's method. So these are the available methods we have, but mainly we are using last year's, Cauchy's, and Fisher's ideal method. So these are the three main methods we are having. Now let us see that one by one. So the very first we have is last year's method. So in last year's method, uh, last year's price index. So always we are denoting the price index is denoted by P1. So the last year's index is given by, so assigned by to the each commodity or the quantities assumed in the base year for the price indices. So for quantity index rates, we are used for all the price of the commodities in the base year. So according to last year's, the price index is given by P01 equal to summation P1 Q0 divided by summation P0 Q0 into 100. Okay, so that we have. And um, so the last year's method in this formula, this is the formula for finding the last year's method. So last year's method is given by P01. The price index is given by P01 equal to summation P1 Q0 divided by summation P0 into 100. So this is the price index here. And the quantity index Q01, it is given by summation Q1 P0 by summation Q0 P0 to 100. So this price index means always it is usually price index is given by summation P1 by P0. So here we are making use of that quantity for the base year. We are taking multiply and divide by both denominator and numerator by Q0. So Q0 we are taking. So summation P1 Q0 by summation P0 Q0. And you see in the quantity index we have Q01. So Q01 is given by quantity index. Always we will have summation Q1 by summation Q0. So in this one, with respect to price, we are taking. So P0 by P0. So numerator and denominator multiplied by P0. So summation Q1 P0 by summation Q0 P0. Since we are calculating in terms of percentage, we are taking this as into 100. Okay. So this is the formula for calculating the last year's index number, price index number, as well as the quantity index number. Now it is noted that it is most popular for constructing the consumer price index. So it is therefore considered as aggregate expenditure method, which is one of the most method for constructing the consumer price index. Since each index number depends upon the price and quantity of the same base year, we can compare the index of one period directly with the index of the other period. Suppose, for example, if you take the cement price index is in 1995 it is 115, and in 2000 it is 143. So we can consider taking 1991 as a base year. The firm concludes that the price level of limit, there is level of cement has increased by 15% from 1991 to 1995 and has increased 43%. Okay, so 43% from 1991 to so that much of increment we are having. We are calculating last year's index number. So the next one is Ashes index. In this method, uh, quantities are consumed in current year are used as weights in construction of price indices, whereas in construction of quantity index, weights are used the prices of items in the current year. So according to Ashes, the formula we have is P01, price index P01 equal to summation P1 Q1 by summation P0 Q1 into 1. So how we have discussed and that. So summation, usually price index number we are calculating by summation P1 by summation P0. So in constraints we are taking the quantity for current year. So Q1 multiply and divide by the denominator and numerator by Q1. Therefore, the formula becomes so summation P1 Q1 by summation P0. So this is the price index. Similarly, quantity index. So quantity index we have a summation. Quantity index always we are representing by Q1, summation Q1 by summation Q0. So summation Q1 P1 divided by summation Q0 P1 into 100. So that we have. That we have. So comparison of this last year's and the past year's increases we have. In the practical point of view, we can have as last year's index is usually preferred over the past year's